Let's talk about dividing decimals. The principles for dividing decimals are key. You've learned some of this from long division principles, and that's what you use with decimals as well. Some terminology is good to know, and your book does a good job of reminding you that the divisor is that which is technically in the denominator, and the dividend is that which is in the numerator. So like 25 divided by 5. So the dividend is 25, the divisor is 5. The solution you get is called the quotient, and then sometimes you will have a remainder. In this particular case I used, you'll have a remainder 0. So your book goes on to start off by talking about the divisor, the dividend, the quotient, and the remainder. These terms are defined, again, most of them we've used before. Now if we look at a situation where we're dividing 655 divided by 100, we know that this problem will become 6.55 because we're moving the decimal 2 times to the left to get 6.55. Another way of writing this in a sense is 6 and then 55 over 100, which is if you do 100 times 6 plus 55, you get 655 over 100. So you could convert from the mixed fraction to the improper fraction and all that. But the idea here is when you're dividing in this situation with multiples of 10, no problem. But things can get a little interesting when we're working with situations where the numbers are not neatly laid out. So in your book, they start out by talking about 637 divided by 100, and they show you using long division what happens there. 100 goes into 637 6 times. 6 times 100 is 600, and then you work your way down and you will get to a point where it ends. So basically, they use long division. They put 100 and 637. 100 goes into 637 6 times. 6 times 100 is 600. You bring down a 37, right, if you subtract. And then you add a 0. 100 goes into 370 3 times. 3 times 100 is 300. Subtract there, you get 70. And then 100 goes into 700 7 times. 7 times 100 is 700. And you're done. It ends. So that's the example they gave you in the book. Note that adding 2 zeros after the decimal point in the dividend does not change the value of 637. They remind you of that. When they if you put 2 zeros there, it doesn't change the value of the 637. So that's an important thing to keep in mind. The book goes on to give you more practice or more explanations on page 386. And on that page, they talk about dividing a decimal by a whole number. And they give you, divide 23 by 20. In that situation, I'm just going to go over briefly what they have here. In that situation, all you do is you set up the dividend and the divisor. Let's pick up a different problem and use here. So let's see. So if we have a situation like 110 divided by 25, you have a divisor and a dividend, right? So you say how many times does 25 go into 110? We know it's 4 times. 4 times 25 is 100, and then minus. So we can say 0.00 here. Basically, this becomes 10.00. And then, or let's just leave it as 10. And we'll add the 0 as we need to. So 0, and then a 0 again. So 25 goes into 100 4 times. And 4 times 25 is 100. And that brings you to your destination there. So basically, 110 divided by 25 will be 4.4, right? Okay, so that is another example there with dividing whole number situations using our divisor or dividend. Adding zeros to the right. Let's focus in on that section. Adding zeros to the right of the decimal point. Usually one does not immediately see how many zeros to the right of the decimal point in a dividend are needed. These zeros are usually added at each step of the division until the division is completed or the user is willing to terminate the process and accept only an estimate of the quotient. So it's important to note that sometimes you don't need multiples. So like in this case, I don't need that here, right? So the 1 0, bringing that 1 0 down, that was sufficient. So sometimes it depends on what you need at the end of the day. So something to keep in mind, and they give you a good example of that in example 2. Sometimes you add zeros, 1 0, sometimes you have 2 zeros after that number. So let's look at an example of 42.55 divided by 23. So in this case, we have 23 there. That's the divisor, 42.55. So 23 goes into 42 42.55 one time. 1 times 23 is 23, right? So we have 23. That's going to be 42 minus 23. So we have 19, and then we bring down that 5. And then 23 goes into 19 0 times, we know that. But then what about 23 into 195? So if you say 195 divided by 23, that will give us an 8. So 8 times 23. Now we multiply 8 times 23. We get 184. We subtract, so 195 minus 184. So we have 11. We bring down that 5 over there. And now we ask, what about 115 divided by 23? We get 5. 5 times 23 is 115. That brings us to the end of that section of the problem, 1.85. So, decimal division, interesting stuff. But let me show you another way of doing this same problem. 42.55 divided by 23. What if I told you to do it like this? 42.55, so 4,255 divided by 100 divided by 23 over 1. And what if I wrote 4255 over 100 times 1 over 23, which becomes 4255 divided by 2300. What if we looked at it this way? Now we can go back here and we can say 2300, 4255. 2300 going into 4255. How many times, right? You can try 2300 plus 2300 and you say right away, oops, that's 4600. So therefore 1 time. 1 times 2300, 2300. What's left over? What's 4255 minus 2300? We have 1955. Okay, how many times does 2300 go into 1955? 0 times. It doesn't go in at all. Okay, so we're going to set up a decimal there, and then we're going to add a 0. How about 1955, right? I'm sorry, what about 19,550 divided by 2300? What do we get? We actually get 8.5, but in this case, it's just going to be 0.85 after that decimal. But basically, there's a way to look at this and do it differently from what we've seen before. We can basically change the 42.55 into a fraction and then try and work out the answers that way. Now, if calculators are allowed, of course, you just go ahead and divide 42, like right away, you could just do that there and get 1.85. But sometimes you might be better off using this approach if you don't want to worry about decimals. You can convert the decimals to fractions, simplify the problem, and then convert it back to a decimal. That is okay to try that option. So something to keep in mind with these types of problems. Let me mention now, as far as practice for this section, that if you were to do every other odd, that would be definitely sufficient. A lot of problems like this, at this, after this stage, you get to a point where you just, you can use calculators for them, especially with decimal division. I'm not saying you use it for everything, but with decimal division, a lot of times, if you are doing problems in chemistry or physics where you're dealing with decimals, you're generally using a calculator. So just keep that in mind and in perspective. So if you were to do every other odd, that would be just fine. You could skip the word problems on this one. And then it also has some problems, in the 89 range that deal with, working out like a PEMDAS in a sense. You work out the details in the parentheses or multiplication, and then there's division involved. Let me know if you have any questions, but I might send you more specific numbers for this section. But for sure, every other odd is sufficient. Okay, so let's look at a few more things here on page. Let's see, 388, they talk a little bit more there about decimal divisors, and they give you 1.25 divided by 2.5, and they introduce this concept, this idea that you can move the decimal point for both the numerator and denominator and work the details out from there. So instead of 2.5, they changed that to 25. Instead of 1.25, they changed that to 12.5. They did the same thing to both the numerator and denominator. They multiplied by 10. So let me know what you think about that idea. Feel free to review that and then go from there. They encourage you to always write the numbers out as 0.75, for example, rather than just 0.75. That is to avoid any confusion with multiplication partly. So on page 389, they give you more explanations and more practice. If the divisor contains a decimal, they remind you to proceed as follows. Move the decimal to the end of the divisor. Move the decimal in the dividend an equal number of places. So when you have 0.45 and then you have 36.99, you can move the decimal over 2 times here, and you can move the decimal over 2 times. So that becomes 45 and then 3699. So we can do that to simplify this problem. So something that is introduced that is very important here in example 3. And then the rest of this, you just use your principle of long division to work out the details. Using signs with division are the same with multiplication, the same things you learned. If the signs are the same, so a positive divided by a positive, you get a positive. If the signs are different, so like a positive divided by a negative or a negative divided by a positive, you get a negative. So just keep that in mind as you work through these problems. I'll go ahead and set the example also for you for the next one, the U triad, next to example 4. So we have negative 0.0113 divided by 0.05. Now, if you just do the U try it for this particular section and you understand how to do each of these problems and you do it without a calculator, I encourage you to you can move on to the next section, to 5.5. If you can do the U try it problems, in your textbook where it says U try it, if you're comfortable doing that, that is just fine. You can just do the U try it, and you can actually skip doing the odd problems for this one. I'll let you, decide if you want to use that option. So let's look at the next section here. We're looking at an example of this one right here, negative 0.0113 divided by 0.05. And we're going to look at how this plays out in this particular scenario. We can move the decimal place several times. So let's see how many times. 1, 2, 3, 4. So if we do that, we would have 113. And then here we go 1, 2, 3, 4, and we would have 500. So that's basically what would happen there. It would become 113 divided by 500. Now there's a negative involved. So because there's a negative, the answer will be negative at the end of the day. So we have 500 and then 113. And basically we work out the details like you would do if you had long division problem. So in this case, if you have 113 divided by 500, you end up with 0.226. Sorry, my marker is not writing it well there. So let's adjust. 0.266226, and then that negative has to remain. So that's what the answer will be. So 500 goes into 113 0 times. We know that, right? And then we say, well, let's put a 0 here. And then if we put a dot and a 0 there, so then 500 goes into 1130 2 times. 2 times 500 is 1,000, right? And then you continue your work. So you have 130. 500 goes into, we need another 0. 500 goes into 1300 2 times. 2 times 500 is 1,000. And we bring down that 3 again. And then 500 goes into 3,000. So the rest of the work you can show. And then let me know if you have any questions on this one. So the answer is negative 0.226. Rounding is a great skill to have. So let's talk about rounding. So for rounding, if they say convert 5/7 to a decimal and round your answer to the nearest hundredth. So we have 7 out here and 5. 7 goes into 5. We know it doesn't go in, it goes in 0 times. And then we have a 0. 7 goes into 50. How many times? So we know that it's 7 times. 7 times 7 is 49. So we have 1, we have another 0. 7 goes into 10 1 time. 1 times 7 is 7. So 3. Now they said you should round to the nearest hundredth. So if it's to the nearest hundredth, let's try one more. Let's see our test digit. So if we put a 0, so we have 7 goes into 34 times. 4 times 7 is 28. Okay, so we don't have to worry about more steps here because they wanted us to round to the hundredth, and the 4 is less than 5. So the answer is 0.71 if we're rounding to the nearest hundredth. Dividing by powers of 10, we've discussed this briefly already. If you have 5 divided by 1,000, that means that the decimal point technically is moving 1, 2, 3, and then I put it like this. I put a 0 and a 0, so this is 0.005. So when you're dividing, or in this, another way they could have asked this is to say 10 to the negative 3. You move that decimal over to the left 3 times. So that's what would happen in that case, and that's how we get this answer. So they explain briefly the powers of 10 and tell you again that you can move the decimal point depending on what the power of 10 says. What is the power of 10 in question? So you can move it to the left as many times or move it to the right. So if it's 1.25 divided by 10 to the 4th, that's the same thing as 1.25 divided by 10,000. That's the same thing as 0. So you move that 1, 2, 3, 4. So it's going to be 3 zeros before that 125. So that's the way it would work out for that particular question. Order of operations follow the same principle. I'm just going to go ahead and explain the example next to you try it next to example 7. A is 2.1, B is 1.7, C is 4, and D is 0.05. So we have A plus B over CD is the formula that we're supposed to use. So that is negative 2.1 plus 1.7 divided by 4 times 0.05. So negative 2.1 plus 1.7. Let's take care of that right away. So that's like doing 2.1 minus 1.7, which is 0.4 with a negative, divided by, and then you have 4 times 0.005. It's 4 times 0.05. That's 0.2. So you have 0.4 divided by 0.2. So this is going to become negative 2 at the end of the day for that particular problem. So we use that same principle for the next section of the You Try It. Let me know if you have any questions. But this is the section on dividing decimals. A very interesting topic, but at the same time, I also understand that when you actually need to use a lot of it in chemistry and physics, you actually at that point are allowed to use a calculator. So just be familiar with the idea, but then know that using a calculator will be fine when you get to chemistry and physics. Thank you and have a good day.